Welcome tonight. As mentioned, 60 nearly impossible issues for evolutionists to answer. And there's my email address if you care to use it. And without further ado, we have a lot of ground to cover, so brace yourself. Okay, the main objective is we're going to sketch 16 such issues that are mostly scientific and show how, or at least I claim, that the evolutionist responses fall short. When I was studying history of American education many years ago, one of the lessons that we got, which frankly didn't have much to do with education, was the four philosophical schools of thought. I want you to keep them in mind, because these are the ways that we evaluate whether something is true or not. One of them is called absolutism, which means somebody said so. Another is called empiricism, which means somebody tested it. A third way might be pragmatism, which means somebody discovered that something works. And the fourth way is existentialism, which means somebody found that something occurred. Now, of these four choices, the preferred choice for this talk, as opposed to others, is empiricism.
She's flat. The world she's around. She's flat. Look, King, she's around like the apple. She's flat like the pancake. Pasta fazooka. She's around, she's a firm, she's a fully packed. She's around like my head. She's flat like your head.
The Warner Brothers really know how to do it. So you might recognize some of those lines from Here We Go. Columbus trying to battle Ferdinand and his accurate skeptics from Orange County. We need empirical evidence of any claim to accept it as true. I agree with that statement. Not to be an evidentialist, but I agree with the statement. Empiricism I call the dispassionate interchange, where we might have the scientific method. We're comparing a model or a theory versus reality, practical. That's the pragmatic aspect. Other things that we might engage in are collecting, measuring, observing, testing, correlating, cross-correlating, and always with an ever-present questioning skeptical eye. And we may have some skeptics here, and if we do, I welcome your questions in due season. We also modify our conclusions, repeat the above steps, and then revise our hypothesis or theory. And in empiricism, we only have probabilities that go between 0% and 100. Not exactly 0, not exactly 100. We might have a high probability, we might have a low probability, we might have something in between. It's always subject to change depending upon what we have as evidence. We also have non-empirical categories, namely the historical, the spiritual, and the unsensed. These are not available to scientific methods, and they have to be recognized as such. Here's an interesting quote you might have seen from The Blind Men and the Elephant, especially the part where it says, though each was partly in the right, all were in the wrong. This was not said by Rudyard Kipling, but it does come from a famous Indian legend. We also have to keep in mind, we don't know 1/1,000,000% about anything, said by the one who had more patents, at least in his day, than anybody else. General scientific principle, verified scientific laws don't displace other verified scientific laws. So if somebody comes along and says, oh, I have this newfangled thing, ask, what about the old stuff? As was said by 3 skeptical professors at Caltech to Stephen Wolfram at his alma mater on 1 February 2003. And I was there to see this talk and hear this discussion. The new science better agree with the old science.
Do you know what the imagination is?
Oh, sure. That's when you see things, but they're not really there.
Well, that can be caused by other things, too. No, to me, the imagination is a place all by itself, a separate country. Now, you've heard of the French nation, the British nation. Well, this is the imagination. It's a wonderful place.
Natalie Wood versus Edmund Gwynn. That's the quote that's attributable to the Miracle on 34th Street. You see it every Christmas. Here's another one.
What do you mean bursting into my office like this?
Are you a licensed psychiatrist?
What business is it of yours?
I have great respect for psychiatry and great contempt for meddling amateurs who go around practicing it. You have no more right to analyze Alfred than a dentist has to remove a gallbladder.
I beg your pardon.
Your job here, I understand, is to give intelligence tests. Passing yourself off as a psychologist. You ought to be horsewhipped. Taking a normal, impressionable boy like Alfred and filling him up with complexes and phobias.
I think I'm better equipped to judge that than you are.
Just because the boy wants to be good and kind to children, you tell him he has a guilt complex.
Having the same delusion you couldn't possibly understand. The boy is definitely maladjusted, and I'm helping.
Maladjusted? You talk about maladjustment. Seems to me that the patient is running the clinic.
I won't stand. Leave this office immediately.
Now, either you stop analyzing Alfred, or I go straight to Mr. Macy and tell him what a malicious, contemptible fraud you are.
Get out before I have you thrown out.
There's only one way to handle a man like you. You won't listen to reason. You're heartless. You have no humanity.
Are you going to leave?
Yes.
We all have our days, don't we? Take a listen to this particular
I have
quote
great
out.
respect for psychiatry and great contempt for meddling amateurs who go around practicing it.
It's about the way I feel about science. Mm-hmm. Note the part in red there. So, a word also about extrapolation and interpolation. Does anybody know what extrapolation is or interpolation? Can anybody say one? Of course, Gary, yes. One of them two.
Well, interpolation is measuring something between two known measured spots. Extrapolation is going outside of where you measured something.
Mm-hmm. I would say interpolation is where you're trying to fill the points in between.
That'd be another way of saying it.
Okay, yes. In any event, the two are similar, but one of them is subject to greater uncertainty. The extrapolation is high risk of producing meaningless results. In other words, extrapolation is much more subject or likely to encourage mischief. We have a hard enough time with interpolation, for which there are no universal methods, how much less extrapolation. And yet when we go back into the unobservable, unrepeatable past, we end up with all sorts of mischief that's possible. Especially since you can't go and peer back there beyond what current artifacts you might have. You can't repeat the matter of experimentation and collect data, unlike going into the future. Now we're into the main part of it. I'm going to be speaking on what I might call universal evolution, or at least that's my backdrop. Evolution just means change, nothing more than that. It may include any of those subcategories you see, besides biological at the bottom. And that's the definition I'm going to be assuming, that evolution in fact includes all of those things. But I'm more referring to the evolutionist and what he does when encountering things that he sees are within his scope. Here's a brief review of thermodynamics. The best you can do is break even. You can only break even at absolute zero. You can't reach absolute zero. You must play the game. Therefore, you must lose. This is thermodynamics in a nutshell. And those are a couple of the books that I used in them, and you can see them over here. Here are the 16 issues then, with those in mind. First one is, why does anything exist? Second one is, did the universe always exist? Third one is, did the universe cause itself to exist? Fourth one is, how can the universe avoid heat death? Fifth is, how can any material travel faster than the speed of light? Sixth is, what is the origin, transportation, and distribution of carbon? Seventh is, how do any stars exist? Eighth, how do any moons form? Ninth, what is the ongoing source of long-term comets? 10. How do any elements heavier than iron exist? 11th, how do peptide bonds exist? 12th, how do proteins have only L amino acids? 13, what turned non-life into life? 14, how does metamorphosis occur? 15, how do major morphological changes occur? 16, what creates information from gibberish? I'm sure you automatically have all the answers to all those topics just as soon as I said them, right?
Oh, of course.
So I could just wrap up the talk right here, right? No? Oh, well, maybe a little bit of explanation might help. All right. First one is, why does anything exist? Well, if nothing exists, we don't have any space, no material, no people, no meaning, nothing. In fact, from nothing, nothing comes. It's been said in philosophy. I would propose to you that this is the starting point. Roget's Pocket Thesaurus. It's more than just a treasury of synonyms and antonyms, or 1,000 categories to characterize the language and its structure. Category number one is existence. Stands to reason that if it is, the latter categories might have something to do with the possible causes of existence. In other words, it forms a bookend. Along this line, we not only would have to ask the question and answer why does anything exist, but why this particular amount of mass? It's been said there are 10 to the 80th atoms. Why not 10 to the 79th? Why not 10 to the 81st? And why this particular distribution, whether in the universe, on the Earth, or anywhere else? Well, one might also ask the question, why does the amount of matter greatly subsume the amount of antimatter, if you expect an equal amount of each? More recently, we have encountered those who would argue quantum fluctuations. And what is that said to be in the popular parlance? Nothing creates everything. That is, nothing creates a particle and an antiparticle. They could come back together anytime they wanted to, but meanwhile, all sorts of particles and antiparticles can keep flowing out of nothing. Really? What would happen when a particle and an antiparticle come together? They would annihilate each other and form energy. So in other words, we have a violation of the first law of thermodynamics. That is, we could create unlimited amounts of energy from nothing. That's not what's actually touted. Instead, it's an already existing energy field out of which the particle and antiparticle come and into which they can go. But that doesn't explain the existence of the energy field itself or its origin. Next question. Did the universe always exist? We might ask from the previous slide, does the universe exist? Well, we would say yes, it does. That's kind of like an application roughly of the first law. But did it always exist? No. Otherwise, we wouldn't be here. Everything would have already dissipated an infinite time ago. So we have two possible choices. Either the universe is open or closed. If it's open, we could have entities like God come in from the outside. On the other hand, if it's closed, we have no escape from the thermodynamics, which I'll mention later. Third, did the universe cause itself to exist? I've had people answer that first question, no. And when I tell them, I've had them answer yes. And when I tell them, no, it can't be the case, they come along with this question, they answer this one yes too, even though they contradict each other. No again, because otherwise the universe would have had to have existed before it existed to cause itself to exist. Or the universe would have had to exist and not exist at the same time and in the same context. That's a logical contradiction either way. I could also build a cosmological argument on that basis. Let's start with the first question. From application, does the universe exist? We say yes. Did the universe always exist? We said no. Did the universe cause itself to exist? No. Therefore, there is no material cause to the universe because everything else is subsumed in the questions that I just asked. What alternatives are there? Well, suppose there is no cause. In that case, it's unscientific. It belongs in the realm of existentialism, which was one of the earlier schools of thought that I mentioned. All right, let's suppose it still does have a cause. Well, then it must be immaterial. Now choose from the following list of possible causes. Fairies, leprechauns, gnomes, my favorite flying spaghetti monster, God, you add to the list. Oh, by the way, only God even has any testimony. So if somebody tells me that my theory is no better than that of a flying spaghetti monster, I will say in return, hopefully kindly to the individual, I don't believe in flying spaghetti monster. You do. And I never get an argument at that point. It is not the creationists who believe in flying spaghetti monsters. It's a way to turn the tables on people who say things like this. We can also rearrange the cosmological blocks to get a flow chart. Does the universe exist? If it doesn't, you belong in an insane asylum. Yes. Does the universe have a cause? No. Unscientific. Yes. Is the cause material or immaterial? So suppose it is material. Did the universe always exist? No. No. Otherwise, it would violate the second law of thermodynamics. Did the universe cause itself to exist? No, because otherwise it would violate logic, and we're back to the immaterial causes that we saw earlier. It's powerful stuff when you use it. Convinces a good many atheists, agnostics, and skeptics that they're quite limited in what they've been saying, and they've been running on empty for all these years. I just went through a troubleshooting step with one of the major people in this area, and he got blown away by this argument. Issue 4, how can the universe avoid heat death? Well, according to the foregoing, we can't. It's a second law of thermodynamics consequence. Now, there are people out there who try to rescue it, despite the fact Le Chatelier's principle, which is the principle that says if anything shocks something out of equilibrium, it is driven back to equilibrium, and there's no stopping until it gets back within equilibrium. Well, Schotti's principle otherwise guarantees the complete dissipation of the universe. There's no useful energy left, and the universe is fully deteriorated after that point. Is there any hope for a steady state or constant universe? Well, let's come back to one of those old statements that we said earlier. The new science better agree with the old science, and the old science is the thermodynamics are still there. They didn't go away. Issue 5. How can any material travel faster than the speed of light? Well, you might have thought that none could. We don't have any observations to indicate that, but there are some people who are involved with the Big Bang, and it requires, in certain cases, a sudden hyperinflation. At about 10 to the minus 31 seconds, I've seen other values. Otherwise, we have no agreement of the ambient temperature of the universe in one part agreeing with another. It all seems to be stationary all throughout at 2.7 degrees Kelvin. Anyway, how would anybody know if there was such a hyperinflation? Why would we not say that it's 10 to the minus 32 seconds or 10 to the minus 30? And why only at one time? Why wouldn't we see a number of them? And there's also a problem that was claimed to have a solution in 1982, and some of us aren't so sure. It's called the graceful exit problem. And that is, if you get it to hyperinflate, that is up to this high level, what brings it down back to where it was before? I asked Hugh Ross's reasons to believe, the old Earth creationists, about that sort of a problem. I didn't, unfortunately, get to talk to Hugh himself, but his staff for a number of weeks a few years ago, and they have no answers to this issue, nor do they to the next. What is the origin, transportation, and distribution of carbon? I'd like some help from the audience. In this picture, you see what examples of carbon, or what don't you see as examples of carbon? One example from each participant, please. Who would like to take the first one? Name any of them, any examples of carbon in the figure. Yes?
Moss.
Moss, vegetation, yes. Sometimes called chia material. Next, any other?
Diamond.
Diamond is one. What about another one?
Coal.
Who said?
Coal.
Coal. Any others? C or not C?
No graphite?
I consider the coal close enough. Anything else?
I don't know, some carbon in the atmosphere.
Very good. What? Name one.
Carbon 14,
Carbon dioxide.
and then other, oh yeah, carbon dioxide.
Carbon dioxide. What else?
Carbon monoxide.
You're the first person to get that right since I've been giving these talks. The first one to come up with that. Any others?
Our very bodies.
Yeah, but they're not in the figure. They're not invisible in the figure either. Any others? We're trying to use it as a fuel.
Hydrocarbon.
Gas.
Huh?
Oxygen?
No, oxygen's not carbon.
Hydrocarbon.
Hydrocarbons, what? Like, for example, what's a
I don't
simple
know.
hydrocarbon?
Is that like petroleum? No. What is
This
it?
thing could come from petroleum, the one I'm thinking of. How about methane? In any event, there are a whole bunch of chemicals that have carbon in them. My question isn't whether or not they have carbon. My question is, where did the carbon come from in the first place? That's my question. And to that end, there was a Nobel Prize that was awarded for work done in the 40s and 50s on that thing. It was said to, the suggestion came from what's called the triple alpha process. I don't know if any of you know what the triple alpha process is. I imagine not. Okay. Helium, which each atom came from two hydrogens from a star. We have yet to talk about how stars get there. Normally, the process would end right there because, among other things, helium is a noble gas. The proposed suggestion is that two of these heliums formed atomic weight 8, which is, by the way, unstable according to the book that you see there. But before it could fall apart, in 10 to the minus 15 seconds, a third one joined the fray and gave us our atomic weight 12, which we recognize as carbon. It can be only done, it can only be done at one nuclear resonance, only in red giant stars, and can be disseminated only by supernova. In other words, it's an extremely improbable process. Now my question is, how did that carbon, if it be so formed, get to the Earth? I call it the original dark matter, carbon. Well, let's see.
Carbonaceous contract.
Supposedly it's a supernova. This is always the magic wand if it isn't time. Where's the nearest red giant star to us? 33 light years at a minimum, maybe 40. Ask yourself, how is that carbon in the red giant star, that supernova, going to jet its way to the Earth, such that we have this miles deep, thousands of miles long, solid coal beds, several places throughout the Earth. In fact, a number of places, according to this chart of world coal deposits. Notice how irregular the distribution is. We, for example, have no carbon in South America, where you might expect to see a lot of vegetation. Or even, for that matter, the number of places in Africa, especially southern Africa. There's some, but not a whole lot. In other words, carbon is not deposited uniformly, scattered across the face of the Earth. If it were, it would not be economically viable. We wouldn't have coal deposits that we could go after. Okay, so somebody has thought, well, maybe we have red giant stars in the current volume of the universe. Well, first of all, somebody show me that there is observational evidence for such red giant stars. I'd yet to see that. But even if there were, wouldn't a supernova scatter everything out in all directions anyway? The supernova only explains at most that it could be transported. It doesn't explain how it could be in concentrations. Distribution is such an important topic to bring up in these conversations because almost nobody believes exists. You have to have them before you can even begin to talk about the carbon in them. Let's assume that you have all the mass confined to an infinitesimal volume. That's a volume that is arbitrarily small, but not exactly zero, and that you start off with our Big Bang. You might want to start off with some other scenario. Let's use this one. Now let's recall Newton's first law. An object in motion tends to stay in motion, an object at rest tends to stay at rest. What will become of the particles from a naive point of view that explode out from or expand out from a Big Bang? They'll just keep going and going and going, and especially if they're gases, mind you, and they'll never stop going away from each other. Whereas what we need for a star is for them to be coming together and together and together. We have a hard enough time as it is on the Earth trying to compress gases. We need a specific device containing a much smaller volume. And notice also that to get that solid or liquid from the gas, we need to have the temperatures become colder. What supposedly happens in this case? Particles in the cold of space, 2.7 degrees Kelvin, become hotter and hotter and hotter until they become much hotter than anything on the Earth. Also, you have to maintain the star somehow and lift the compression device. Won't that cause the particles to go out anyway? No, there really shouldn't be any stars with this naive point of view. There's a flip side too. Assuming you have a generous 20 billion years to work with. It's been said there are 10 to the 21st stars in the universe. How anybody came to that number, I don't know. But if you divide 10 to the 21st by 20 billion, you can come up with 50 billion stars every year. That would be the average number that you'd have to be producing every single year for every one of those 20 billion years. Seems to me we get excited if we even hear things having to do with the creation of one star. I don't remember seeing on the internet, on the radio, or on the television screen anything having to do with our having met our quota last year of 50 billion stars. Now, of course, it could be lower over time or it could be higher over time, but the point is it's an average of 50 billion stars. Let me know if you see any such reports, because after all, I'm an empiricist. You've got some new evidence. We have to take it into account. We'll be glad to fold it in or accommodate our views. I have fun with this one. How do moons form? Let's assume you even have stars and orbiting planets. Now, I've got a silly question to ask. How do you get solid moons from gaseous planets by blasting the planet? Jupiter, Saturn, Uranus, Neptune are gaseous planets. They have most of the moons, by the way, in the solar system. Or you could adopt the nebular hypothesis, which is to say they're all forming at the same time. Well, then I got a question, why are some of them nebulating into gaseous planets and the others into solid moons? Different phases of material. But we have a moon here on the Earth. Let's see what happens when we try to get a moon from the Earth. The most likely scenario is if you have something impacting it, it'll just stay there. That's the most likely thing that'll happen. It would have to have, in other words, a volume, maybe about as big as a moon to begin with, and it would have to be traveling much faster than we know of. But let's suppose you even have that. Let's suppose you have it impacting the Earth in maybe, I don't know, the Pacific Ocean region, but there better not be an ocean out there, because otherwise it'll be blasting an ocean out. Okay, so there's no ocean. The particles, if they're not going fast enough, are likely to just come up and just flat on the ground again. There's your moon experiment. But let's suppose they even get to the point of 1 to 2% of the Earth's radius, which is called Roche's limit. They will be fragmenting all the way up because of tidal forces, and they will come raining in a shower, and they will still be the end of your moon experiment. But let's suppose that you even get beyond that point. Then you have to impact a tangential velocity to the supposed moon that has been created by these small particles. Mind you, they didn't compactify by anything either. And there's no known source for a tangential velocity because it would be perpendicular to the velocity coming straight out of the Earth. And anything else, by the way, besides that kind of an angle is even less likely to form a moon. Yeah. Now, other people have regarded something saying, suppose we have something already coming along, it's going to capture the moon. Well, first of all, that's being regarded in modern times as being too coincidental. You'd have to have something that would cause the moon to be in its current orbit, not the one that would result from directly impacting, where it would be most likely geosynchronous. Instead, it would have to be once every 28 to 30 days instead of once a day. I got another question asked, where are the evidence of other tries? I mean, we get scared enough as it is if we see a meteorite come along. Witness the events of about 1.5 years ago. Imagine what would happen if you saw a moon coming in your direction. Here's a statement from Wikipedia. Since tidal forces overwhelm the gravity that might hold the satellite together within the Roche limit, no large satellite can gravitationally coalesce out of smaller particles within that limit. This even assumes you have the compactification, which nobody, I think, ventures even a comment on, or that you have the tangential velocity. That way right there. In fact, those of us who have been in aerospace know that it's an exacting science to put anything into orbit. This is a long paragraph, if you want to see it later, that has to do with the capture theory. I'll just note that in the bottom, those who hold to oxygen isotope ratios have an argument on their side. I'll have to skip past this, it's kind of long to read. What's the ongoing source of comets? I'm going to be speaking about long-term comets. The short-term ones are about 200 years or less. That is as far as how their orbit is concerned. They're highly eccentric, as you know. They might be explained by what is called the Kuiper belt or the interplanetary disk. It's the long-term comets that are the problem. Some of them may have the same sources as the short-term, others may not, and it's the ones that don't that we have the problem. And for this, the Oort cloud was hypothesized, spelled O-O-R-T. What might you ask is an Oort cloud? It is like an automatic picture of dirty snowballs. Conveniently, of course, to make up for the comets that are lost in the sun or otherwise lose their material. It would have to be, the center of it would have to be way beyond the solar system, or it might be scattered over a larger volume. There's no actual evidence for something we can point to and say, okay, there's our Oort cloud, and it's the entity responsible for putting out those long-term comets that we cannot account for otherwise. And there is no other hypothesis yet. Continuing our sketches, number 10. How do any elements heavier than iron exist? This is probably a topic you've never heard before, if I had to guess. Here is a chart of the periodic table. We see carbon from before. Let's see. Oh, I'll just have to leave it. There was another one I had for iron. Iron is above the fourth row, you see the fourth row, it has a beige thing? To the left of it, it's magnesium, and to the right of it is cobalt. That's where iron is located. Notice this element is 26. It's way far away from the others. This is a graph of the binding energy per nucleon, sometimes called average binding energy per nucleon. You could find it in that orange textbook right there in chapter 9. Notice how to get from hydrogen, which is on the left side, element number 1, you have to pass through some ripples to get there, which is problematic to begin with. But if you do, like for example that carbon problem, then you might actually make it up to iron, Fe, which has an atomic weight of 56. And there the process would end. Because if you try to fuse any more than that naturally, it will become less and less stable. The higher it is on the graph, the more stable. In other words, iron is more favored to form than any other element is favored to form. In fact, the chart also shows that to get all the other elements, you have to start from already existing higher ones like uranium and go through fission. This is a problem. It's a big problem. What's the proposed solution for this? Our old friend, the supernova again. But of course, if a supernova is driving the process, how will you ever get anything concentrated enough to be economically viable? Like ores and mines and so forth. Gives me pause for thought. In any event, the nucleosynthesis methods currently oppose that graph. They invariably assume that, and they don't explain the transportation and distribution, which is the point I was just making. In other words, how do you get reserves of gold, of uranium, of lead, of anything heavier than iron, if it's being scattered out in all directions? Here's a chart of the world's mineral deposits. You might want to come up and see it later. It's a little bit hard to see right now. But you see that it's not uniformly distributed here either. In fact, most of the precious metals are located in South Africa or Russia or China in some cases, which creates some interesting political controversies as a result. Next, how do peptide bonds exist? What we see in front of us is what is called the condensation of glycine. I'd like to show by example what I mean by peptide bonds, but I have to first introduce what is meant by an amino acid. This is a molecular model of an amino acid. On this side, this is a nitrogen atom and 2 hydrogen atoms. The picture has a slightly different color to these things. On the other side of the amine group that I just described is a carbon with a doubly bonded oxygen, a singly bonded oxygen bonded to a hydrogen. Carboxylic acid, COOH. This is a base, this is an acid. This is a hydrogen atom, and this is a functional group. It may be another hydrogen atom or any of 19 other functional groups. Now, yes,
Left or right?
I'll get to that in a moment.
Okay.
And by the way, we'll take all other questions at the end of the session.
Sorry.
Thank you. Now then, you see that in this particular figure, the color is a little bit different. The colors in this figure, the nitrogen is actually blue and the oxygen is red. You see that with this oxygen on the left and nitrogen on the right, you see that something dropped out. What is that thing that dropped out of the bottom? What do you suppose that is? Well, I said what red is and what, and the rest of it, by the way, are hydrogen. So what do you think that is?
Water?
Water?
Water is correct. Have you heard that tale that says that we came from a warm little pond? Just how is that going to occur? When a water molecule must drop out, not be absorbed by the amino acids. This is a problem. Here is a chart showing how these are formed, if they can be. Notice the OH group on the left, on the right side of the left amino acid is trying to combine with one of the hydrogens from the amine group of the other amino acid. Those two are both amino acids. Notice that a water molecule has somehow gone away, floated off. And there we have our bond, our peptide bond. Proteins form by chains of these peptide bonds being formed. As you can see on the bottom, R1, 2, 3, 4, 5, and 6 are the functional groups. Remember I said that they're colored red in this figure? That is how proteins form. In the open, they can't. We already went through why they can't in water. Now, let's suppose instead they manage to find themselves, or to find each other on dry land, since that's the only alternative you have. In that case, then we have to ask, what's the atmosphere above it? It's either oxidizing or reducing. If it's oxidizing, then the oxidizing agents, whether they be oxygen or otherwise, will come along and destroy the bonds between the two amino acids and maybe the amino acids along with them. On the other hand, if it's a reducing atmosphere, then that means there's no ozone and the UV rays can come in and they will destroy the bonds and maybe the amino acids with them. In other words, we have a chicken and egg problem. By the way, do you know which came first, the chicken or the egg?
Both.
God.
Both.
But of the two, a hen and a rooster came first. It wasn't Adam and Steve Rooster, it wasn't even Guinevere Hen, it was Adam and Eve Chicken. Without the peptide bonds, we have no proteins, we have no enzymes, we have no life. And don't forget, without biochemistry, it's amino world. How do proteins have only left-handed amino acids? Here by way of illustration are two amino acids. Can you see that these two are mirror images of each other? Can you see that, everybody? All right. You can also see the figure, that they are mirror images of each other there. Sometimes they're called stereoisomers and enantiomers, chiral compounds. It's carbon surrounded by 4 different entities. Many inorganic compounds also have that property. What happens in a laboratory? If we start off with neutral ingredients, neutral environment, neutral energy source, what will happen? 50-50 mixture of the two. Now, you might end up with something in the environment like, say, soil clays, which might drive it a little bit away from 50-50, maybe 1% in a given direction. Or you might have the Murchison meteorite, which landed in Australia on 27 September 1969 with a much bigger ratio, but not 100-0. Every single amino acid of every protein in every species is only left-handed. There are no right-handed ones. There are right-handed amino acids in other structures like bacterial cell walls, which keep the enzymes, which are proteins, from dissolving them. If a protein, by the way, ever encounters, if the bacterium ever encounters an amino acid that's right-handed, it will disassemble it, reassemble it into a left-handed one, and then digest it if it can digest it. Isaac Asimov, the late scientist, offered no scientific reason. I read a whole paper on this that was given. The bottom line is he said, well, it just happened that way. And I would have asked him, across the entire face of the globe? Yeah. Now, one might ask, well, what about mixtures? Well, mixtures don't work as well. In fact, that book in the middle even says why they don't. But it doesn't answer the question of why you don't have all right-handed chains. They form equally well. For those who are a little bit more academically inclined, I'd also like to mention that the central carbon atom, see this is an embedding of, say, an amino acid, say all the ones in red or all the ones in blue. In other words, you can embed the tetrahedron, which is the basis for it, in a cube. I don't think it's any mistake or coincidence that 2 of the 5 perfect solids are just such this way, that one embedded into the other. And you could even go to the trouble of computing what the bond angle is. Maybe some of you have had some chemistry. You might recall that if you go from any one of these, like say red ones, to another one, through the middle one, which is gray, if you have equal components, like say in our methane molecule, you can use ordinary Euclidean geometry and the law of cosines to come up with the angle, which is the arc cosine of -1/3, approximately 109 degrees, 28 minutes, 16 seconds. We didn't see that until our freshman chemistry book, but it can be done as an advanced exercise in high school, and I wish they would. If you have unequal components, you might be able to have a better proof as to what kind of amino acid you have by studying the stretching or the contracting. Now, in this book, I'd like to read something about the matter of amino acids on page 236. Indeed, we deal with optically active substances to an extent we may not realize. We eat optically active bread and eat optically active meat, live in houses, wear clothes, and read books made of optically active cellulose. The proteins that make up our muscles and other tissues, the glycogen in our liver and in our blood, the enzymes and hormones that enable us to grow and that regulate our bodily processes, all these are optically active. Naturally occurring compounds are optically active because the enzymes that bring about their formation, and often the raw materials from which they're made, are themselves optically active. As to the origin of the optically active enzymes, we can only speculate. The situation is no better now than when this book was being printed in 1972. And the problem was known for more than a century before that. 13. What turned non-life into life? Let's suppose I just give you a dead dog. It's been dead long enough, 3-4 days. One small task, Hercules. Breathe life into the dog. I've given you everything that it has. Its brain, its liver, its spleen, its lungs, its spinal column, its nervous system. Just breathe life into it. Task? Aren't you Hercules? Well, maybe the task is bigger. In fact, if we can't breathe life into a dead dog, what makes us think that we can breathe life into materials made into a dead dog? There is no spontaneous generation. There is no Goldschmidt hopeful monster. And no, the scenarios about RNA doing all the work are just hypotheses. Life only comes from life. That's all we've ever known, as shown by Pasteur et al. 14. How does metamorphosis occur? Now, there are two different kinds. One of them is insect and the other is amphibian. I'm going to talk about one aspect of insect metamorphosis. This is a chart showing complete metamorphosis. You can see the egg, the larva, the pupa, the adult. Let's suppose that I give you 3 of those. I get to choose which 3. Let's suppose that I give you that the adult lays eggs, the eggs hatch into larvae, and the larva into pupa. Would somebody please tell me how that pupa, in its mushy state, not in control of its own destiny, turns into an adult? I have quotations from all camps at this point, the young Earth creationists, the old Earth creationists, and the evolutionists, who all admit, even in the last 5 years, it is a mystery. And ignorance is no answer. If somebody tells me, well, we'll just wait until science gives us an answer, I'll just sit there and wait. And wait. And wait.
You might want to look at metamorphosis. Most insects, about 87%, undergo a complete metamorphosis. That is, a larva, such as a caterpillar, builds a cocoon or chrysalis around itself. Its body inside then disintegrates into a thick pulp-like liquid. Days, weeks, or months later, the adult insect emerges, one that is dramatically different, amazingly capable, and often beautiful, such as a butterfly. The food, habitat, and behavior of the larva are so different from those of the adult, it's hard to imagine. What mutations could improve a larva? Certainly none that destroyed its nerves, muscles, eyes, brain, and most other organs, as occurs within the cocoon. So even if the larva improved, it later ends up as mush. From the evolutionary standpoint, liquefying complex organs is a giant step in the wrong direction. Millions of changes inside the thick liquid never produce something survivable or advantageous in the outside world until the adult completely forms. How did the genetic material for both larva and adult develop? Which came first, the larva or the adult? What mutations could transform a crawling larva into a flying monarch butterfly that can accurately navigate 3,000 miles in a brain the size of the head of a pin? Indeed, why should a larva evolve in the first place? Because it can't reproduce.
Dr. John David Lehman. 15, how do major morphological changes occur? Here is a suggested chart. Notice the pictures: fish, amphibian, reptile, bird, mammal. To go from a fish to an amphibian, you'd have to go from no metamorphosis to metamorphosis. Your heart would have to change from 2-chamber to 3-chamber. To go from a reptile, from an amphibian to a reptile, you'd have to lose the metamorphosis that you gained, and the fertilization would have to go from external to internal. To go from a reptile to a bird, cold-blooded to warm-blooded, and scales to feathers. To go from the same reptile to a mammal, instead you'd have to have scales to hair. If you wanted to pursue the alternative that people don't advocate, and that's from birds to mammals, you'd have to go from wings to hands, paws, and hooves, and from feathers to hair. Not one of these transitions has any reasonable chance of being answered anytime soon. In fact, consider the following.
Well, never mind. Evolutionists still insist that feathers evolved from reptile scales, specifically dinosaur scales. And to prove the point, they say that feathers and scales are so similar you can hardly tell them apart. Have you noticed that? One of the first people to say this was Gerhard Haumann back in 1927. In his book, The Origin of Birds, he says the most striking peculiarity of birds is their plumage, which apparently has nothing at all in common with the scaly covering of reptiles. So much more surprising is it, on examining these structures in the microscope, to learn that the feather is nothing but a further development of the scale. Alfred Romer, very distinguished evolutionist, says birds have been called glorified reptiles. Feathers are in reality almost their only distinctive feature. And he says, although these structures seem quite different from the horny scales that cover a reptile's body, the difference is in reality not very great. Well, you can look in your Encarta encyclopedia, if you have one on your computer, look up feathers, and they will confidently declare that the feather is a horny outgrowth of skin peculiar to the bird, but similar in structure and origin to the scales of fish and reptiles. So I thought we'd do a little test. I had a laboratory technician that worked for me that had a pet boa constrictor. And I said, hey, the next time that little rascal sheds its skin, why don't you bring it on in and we'll look at it in the microscope, because I understand you can hardly tell a reptile scale from a feather. And so she did. She waited, and when this little rascal shed his skin, and by the way, I want to point out that no snakes were destroyed to do this study. We waited until they shed naturally. She brought the skin in, we put it under the microscope, and we magnified it. And this is what a boa constrictor scale looks like here. You can see the others around it. And as the evolutionists have told us, if you look at them in the microscope at least, they are remarkably similar to a feather. So then I took a picture of a feather, and I want you to see if you can tell the difference. So you may want to clean your glasses or something right now. If you got this one in mind, okay? If you get confused, just look at the top. It'll tell you which is which. Okay, that's the scale. This is a feather. What do you think? Should I go back and forth? You got it down, or... I mean, why do they say they're similar when they're absolutely not similar? In fact, I'll go further than that. They are totally different. Their mature structure is dissimilar, their function is dissimilar, their embryological development is dissimilar, their mechanism of growth is dissimilar, their mechanism of replacement is dissimilar, their chemical composition is dissimilar. And let's just look at the obvious. Scales are like folds in drapery, like drapery pleats. It's all one sheet. That's like when a reptile sheds scales. He doesn't shed them one at a time or two at a time, does he? The whole thing comes off as one sheet. In fact, reptiles typically have two layers, won't they? An outer layer and an under layer. When they shed the outer layer, then the under layer is exposed. Why do they do that, by the way? Why do they shed their skin? Because they're growing. Now, I want you to think about this. You get a box of the mail, and you're wondering what's in the box. You open up the box, you know what's in the box? A bigger box. So you shed the outer layer because the under layer is bigger. You got to think about that a little. Let's look at that boa constrictor skin. The tail's in the direction of the arrow. So to your upper right, that would be the tail. I don't know, a quarter of a mile up there or something like that at this magnification. And you can see the scales are arranged in rows, sort of on the bias with the long axis of the snake. If we get a hold of the right side and flip it over like the page in a book, this is what the underside of the skin looks like. And so now the tail's in the direction to the upper left corner. And again, for those of you in the cheaper seats, let's magnify this a bit. This is where one scale just fit right underneath here. It fit right in there, so when the skin pulled off, that scale pulled right out of that pocket, like taking your hand out of a glove. And that's the way the scales are put together, is one continuous sheet. Now, feathers are completely different. Feathers grow out of follicles, just like hair. Hair grows out of a hair follicle. Feathers grow out of a feather follicle. But I'm here to tell you there's no such thing as a scale follicle. Now, what is a follicle as it relates to feathers and hair? It's a tube-like depression in the skin. You see it here. Goes down deep in the skin. All of the growth occurs in the bottom in what's called a growth collar. The feather grows out sort of looking like a thick hair. And when it comes out of to the surface of the skin, it all unfolds to make the feather. This is the way the feather follicle looks down in the skin. All of the growth is occurring here, and the feather's alive at this point, but as it makes all of its parts, it dies. It goes through a programmed cell death so that the feather that emerges from the skin is completely dead. This is how it all develops. Inside the shell here, we have what we call a pin feather. If you peel this shell away, you can see that this is the growth region at the bottom. The shaft goes up along the backside there, and then the barbs grow off this growth ring, and those little barbs get longer and longer. They grow from each side and meet at the other side. When the feather comes out of the follicle, this cylinder opens up, the barbs all swing down, and you get this big broad feather out of a hole in the skin that's not much bigger than a shaft. And that's the way each feather grows from living cells, goes through a programmed cell death, and rises up out of the follicle in that way.
David Menton. Last topic, what creates information from gibberish? You might recall from communication classes or otherwise that a communication requires a sender that's tuned to the receiver's tuned to the sender, and a medium which promotes rather than interferes with the communication. Now, suppose you have a bunch of numbers, just a series of numbers. How would you determine whether or not that series of numbers seemed to mimic something that was random or something that was communication? Well, we have little measures that some of us are familiar with. The autocorrelation function and its glorification called the ambiguity function. I won't go into them, but I can tell you that if you want to find out more about them, besides some engineering textbooks, you might want to pick up this big old radar handbook. It's used in virtually every aerospace company in the world by Merrill Skolnick. In the meantime, we have something that very much looks like entropy again. This would be what we saw way back there in the second law. In this case, it has to do with information entropy, that is, things becoming more and more scattered. In any event, we need information. All life structures need the information. DNA codes for proteins and proteins for DNA. You might ask the question, how would you get one to code from the other and the other from the one when you might only have one at most? Fact, this is my surviving copy of a book called Flaws in the Theory of Evolution by Evan Schuth, written by a prodigy of a doctor. The biography is quite something to read, the introduction. And in there, in chapter 2, Mechanistic Origins, he quotes an evolutionist with respect to the reasonable probabilities of getting proteins. How many can we expect to ever get by chance? 3. That's it. Not 3 amino acids, 3 proteins. That is far cry from getting even one living cell, let alone a creature, or let alone anything beyond that. 3 is all you can expect to get. I close this for the moment by asking, how many of these scientists might you recognize? Can anybody give me the name of any of them? Okay, somebody said Newton. Which one? Name the row and number. Top row, which one? Second from the left. Any others?
Michael Faraday.
Pardon me?
Michael Faraday.
Which one?
Top right.
Top one, the rightmost one. Fourth one, yes. Fourth from left. Huh?
Bacon.
No, no bacon. Sorry, no bacon. No bacon tonight.
Hurts?
Huh?
Hurts?
No, no hurts. It really hurts that there isn't any.
Maxwell?
Which one?
Lower left,
Um,
I'm guessing.
yes, lower left is correct. Any others?
Galileo?
No, we don't have a Galileo.
Okay.
Any others? Gotten more right than I've gotten seen before. That's what does that count to? Three so far. Any others?
Any hints?
Huh?
Pascal?
Pascal. No, no Pascal tonight.
Pasteur,
Pasteur. Which one?
I think the middle one on the bottom.
Correct. Any others? 4 down, 3 to go.
Did we mention Boyle?
We didn't mention him, but he's not there.
What about Lord Kelvin? Although I can't see the pictures.
You can't. Well, would anybody care to venture where he might be if he's there? Which one? Nope.
The last one or the?
Last one, third one on the bottom. That's Lord Kelvin. All right, we have 2 to go. That's pretty good. I'm surprised nobody's gotten the one clear on the left on the first row, though.
That one's,
I know
That's
that's so
familiar, I can
familiar, but
Kepler?
Huh?
Kepler?
Kepler's correct.
Wow.
Very good. So that leaves us the one in red who was cited recently as supposedly having more influence than Jesus. Don't know if I agree with that, but he's regarded as being the best of all of them.
Newton?
No, Newton we already covered.
Not Einstein.
Nope,
Oh.
no Einstein here.
Nope.
Reach back into your taxonomical studies, maybe?
Linnaeus?
Linnaeus is correct. The one in red is Linnaeus. What else did they have in common? Well, we don't know about necessarily. One thing we do know is that they were not evolutionists. Some of these people back in those days were, but not too many. And here's a list of 16. Notice number 11, Gary. Different one, huh?
Somebody in Spain?
No. This is a source of reference, or a list of references that I used. Only the ones in green are considered Christian. All the others are secular. This is a list of credits.
Copy.
The end. Now, that means I covered it in exactly an hour. Is there? Do we have any more time, or is that it?
We've got time for questions.
Well, first you're going to do the drawing.
Random act of kindness.
Random. Okay, I'll let somebody else do the drawing thing.
Okay.
Is the prize a random molecule? Is that the idea? A random gas molecule plucked out of thin air?
Is the drawing completely random? That's what I want.
Well, there's no such thing as a truly random. All right, I'll reach and you folks say who it is. Okay, who is it? Okay, all right. It says, first of all, it says ticket.
Oh.
Indiana Ticket Company. Funny, I come from Indiana.
Everybody with a new ticket on?
Do you like 6s and 2s?
Yeah.
666.
Whoever has nothing but 6s and 2s.
A unity?
Who has nothing but 6s and 2s in their ticket? Yours?
I guess so.
Read it, please.
62666. Lucky 6662.
Is the last digit what?
2.
You win.
Number of mail.
She just drew it.
Wow. I did pretty good for not even having a ticket.
Hey, that's pretty good.
And all the rest of
I
you can
guess
say,
that
we
all
was
bunch of
robbed.
business. There you go. There you go.
Okay,
Well, if you
so,
didn't have something to begin with, you can't make one else.
right, it's kind of like trying to create nothing from nothing, or something from nothing, or something like that. Okay, might we have any Q&A here? Any questions? Or do you have all the answers now that you need? Yes?
I have a question about the metamorphosis, because I know that metamorphosis occurs from imaginal cells.
Mhm.
So what happens is that the entire thing doesn't turn into mush, but
Mhm.
most of it does.
Mm-hmm.
And then there's these stem cells that are left over
Mm-hmm.
from the embryonic stage, which
Mhm.
didn't develop within the larva,
Mm-hmm.
and they're like just frozen in time.
Mm-hmm.
And then it developed the imaginal cells I love that name, direct the building of the butterfly out of the soup. So what do you mean by the question? Because obviously what I just explained, I'm guessing you're saying that's not the answer.
The origin of it. That is, how did it come together from what is apparently chance element? And again, if you want, I can show you afterwards quote from each of the three camps that shows that they all regard it as a mystery. Now, authority does not mean anything in the scientific world per se, but it does mean it's worth listening to and evaluating. So I give you that. I take your comments at face value. Yes.
On that same topic of metamorphosis, we observed that back in Darwin's day, the prejudice was that cells were just blobs, and so we didn't understand the complexity of cells until I guess some equipment was come by to examine them and see the structure of them. Do we have a similar situation? We've said that the pupa turns to mush, and not to minimize the mystery, because pretty clearly it is there a structure in that mush that we have failed to observe so far?
I don't know. There's one that we know we have, and that's the heart, because otherwise it wouldn't be able to exist without the heart. But it's the very notion of it turning the mush and then coming out of the mush. In fact, you remember seeing even some of the comments from David Lehman, too, that were somewhat addressing, pointed to the mystery. So you can always run through them again.
And then even if there is a lot of structure there that we didn't observe before, such that we couldn't call it mush anymore, just as we can't call a cell a blob, it certainly remains that that's a mystery, and the endless structure that we haven't yet seen will not make it any less so.
Yeah. And again, Lehman was also pointing out why would a learner can't reproduce. Yeah. So yes.
The other thing is that, along with what she was saying, is that different species of butterflies have different mechanisms or different dynamics. If you thought even if evolution could have caused something like that, you would have thought it would be the same process and same dynamics across the board. But it's different. It's different for different species.
Well, that's a little harder to argue, but I think that any one of them would be difficult to explain by itself. Yeah. Commonality may or may not be any one of them. Any others? Yes.
Can you explain the
what?
Hawking's holes and like?
We didn't cover black holes.
Like the whole thing where you said, did you say anti? He was trying to say how matter happens.
Oh, matter and antimatter.
Yeah. What exactly is his argument?
Well, you'll have to ask him before he passes from the sea, not so many years from now. I guess. I mean, he could live to be as old as Ernst Mayr lived to be 104, but right now he's in his 70s. No, seriously though, I'm reading a book right now on some of these subjects. It's called Cycles of Time by Roger Penrose, and I knew Penrose's name from the pseudo-inverse when I was working in aerospace. And he claims to have an alternative view of things. I'm kind of somewhat skeptical as I read it, but it looks like he's taking a variance on the bounce. Roger Penrose does recognize the second law is real, it's always going to occur. He does recognize the inevitable heat death if nothing intervenes. And mostly what he's known for besides discovery is a thing called Hawking radiation, which is the process by which a black hole spews out all of its energy and becomes completely dissipated until there's nothing but a tiny little pop at the end of it. I'm afraid you'll have to ask him how he came to some of these conclusions. Oh, by the way, he happened to say, a day or two ago, to leave no doubt, he says, there is no God. He said that a day ago. That is, if you had any hope that I believed in one, forget it. That's what it amounts to. Yes?
In my lifetime, I've observed some very interesting things that are postulated and put out for general knowledge. One was about the size of the universe. We finally know how big the universe is. They launched Hubble, and now it's increasingly larger than they ever thought it could possibly be. So they have a new meter to look at, and I was drawn to that for your 10 to the 21st number about the number of stars, and the fact that we've never seen them being born.
Yeah, what people have confused, I believe, is when they see the intergalactic dust, as they call it, and then somehow or another it dissipates and it reveals an already existing star instead of one that was in the process of being made. The trouble is when people say that stars are being born, and they're not talking about Barbra Streisand or Chris Christopherson or the older movies, if they're not talking about that one, if they're not talking about things like that, they still have this problem, in my estimation, that is accounting for the difference between a gas and a solid. Now, in a solid, you might be able to have gravitational attraction, like, for example, something landing into a moon landing into the Earth and just staying there. Nobody's going to say that's going to dissipate per se. That's a far different thing to say that a gas behaves that way. And by the way, in reading Penrose's book, I don't think he distinguished between the two. He noticed there's a difference between the two, but he never said what he believed is the cause of one or the other, and I think the explanation is quite simple, and that is gas dynamics are just what they are. He even refers to Boltzmann and everything else. In other words, he has the requisite knowledge, he should, of what should cause gas dynamics, and yet still this, you can't make a distinguishing factor between that and solid, gravitational. There's got to be something more to it. I have a hard time believing that somebody as renowned as he is would not know that sort of an elementary thing. So maybe that must be a misunderstanding on my part or a lack of understanding. Another question, yes?
Is there carbon on the moon?
Well, probably there is, but how much of, well, I don't know if we've gone to the matter of the distribution of it either. I don't have personal knowledge about carbon on the moon. Certainly we left a lot there. We left a lot of other things there too. One might call them debris, as we're known for doing all over the universe. Star Trek never covers the debris that we leave. Okay, any other questions?
Don't they fly for some junkyards?
Huh?
Don't they fly through a few junkyards in Star Trek?
We got enough, I mean to say all over the place. We got enough space junk as it is, all over the Earth, and if people don't clean it up soon, we won't be able to launch anything without having brought it all down and creating even more space junk. Yes, it should be a movie, Space Junk, the movie. Larry, do you have any questions?
I do. What's the significance of number 9 to an evolutionist?
Well, they do see a stake in this matter. I think it's more on the order of the fact that the comets don't seem to be disappearing quite so much. And there has to be an well, in other words, I should say the net number of comets seems to be about the same for now, plus or minus. And the answer is, well, what causes there to be comets to replace them? Of course, the young Earth creationists would say, well, there weren't that many in the first place, and we're now seeing them disappear quickly, and they're really not being replaced. But they do see a stake in the matter, and so that's why they've hypothesized an Oort cloud to try to get a replacement for them.
But what does that have to do with evolution?
Well, you might ask that for anything up through about number 10. You see, it's not evolution per se in a lot of these, but evolutionists' answers to things they see a stake in.
But why do they see a stake in that? I don't see the.
They see an age of the universe problem with that. That's what they see mostly is so they have to account for a long age. How are you going to do that if the comets seem to keep disappearing? You won't have too many left after a while. But there they are. So, more of that's covered in this book right here, Evolution Cruncher. Any other questions from any quarter at all? Okay, if not, then thank you very much. Bravo. I got a lot of people asking me that in the third talk. If you want to see some real debate, watch the one at CCCM. It's you can see 4 of my talks online. They're called the same name, 16 Early and Possible Issues for Evolutionists to Answer. I have the first 4 talks are online. And there's also a debate that I had with the evolutionists on June 17 in Villa Park, and it's called Do the Laws of Science Comport with Creation? And I have the Stevens brothers largely to thank for a lot of that production work. Okay.
What is your website?
I don't have one. I go to, I should say, they're all on YouTube.
How would you find this debate?
By writing that title into there.
What is the name of it? What did you just say?
The other one?
Yeah, you said that really fast. I was still writing.
You mean
down.
the name of the site or the name of the other title?
No, the name of the other title.
Oh, the name of the other title. Okay. So, Do the Laws of Science.
Oh, my pen ran out. Sorry. Okay.
Help her.
Of science. Okay.
Do the laws of science comport with creation? It's also 8 words in case you get lost, just like this. They're just shorter words. And again, there's the website, I'm sorry, the email address, ddb4chess@yahoo.com. See if I can spin all the way back to the beginning so you can see that.
That would be a kindness, yes. I was slow writing before.
Okay, there it is. There's my email address in case anybody has any questions. I'm sure you will. Yes?
Did you see the debate with Dinesh? He had,
No, I saw the other one on February 4, and I thought that Kim Ham was not very good.
they had, true, but they had a debate where,
That's Gary's phone. Yeah?
they had a debate where there was an audience that came in with their ideas at the beginning, and a good share of them were, they didn't know whether evolution was creation. When it was over, it was disheartening to me that more people left. We didn't lose any ground. I mean, the creationists increased slightly from those who were skeptic, didn't know anything. The evolutionists won that debate.
Well, the truth will never lose. The only question is, what is the truth? We don't have to necessarily point to revelation, although that certainly doesn't hurt matters. What I'm trying to say is, here the evolutionists have seen a stake in these matters, proposed solutions, and they violate the very scientific laws they claim to uphold.
Exactly.
In spades they do. It's not even close.
Well, if you start with an assumption, you have to figure out how to justify your assumption.
I feel like it's false.
Well, does that mean that anything is justifiable then?
If you're firm on your assumption, then you have to make things fit.
Yeah, well, then again, as has been said by some people, you can only go so far before something comes along and things don't fit anymore.